Josh and Sharia and Ryan. Sorry about that. We forgot to end Emma. He's not here. Okay, so this is what we've been doing. It's in the back page of your 3D packet, and we're looking at question number 9. Huh? 20 minutes ago. So catch up quick. Here we are. Yay. So we know that we're trying to find the volume of the sphere, what the capacity of air it will hold, how much air does it have. We worked backwards from the circumference to find the radius, and then we just used our formulas. What did you guys get for the formula here? You can again use the fraction button on your calculator for the 4/3, or just make sure that you put it in its own parentheses. That's important, okay? Either way, I'm going to go ahead and just practice using my 4/3 button on my calculator. So 4/3 pi, and then 4.77 to the 3rd power. So 454.6? Does that look about right to you guys? Okay, good. And what are my units here? Inches cubed. Perfect. Excellent. Okay? All right. So we want to design a cylindrical water tank that holds approximately 5,875 gallons. So this is your job. I want you to design it. Could have a variety of heights, radiuses. It could be short and wide. It could be tall and thin. I don't know. I just want it to hold that many gallons of water.
What is it?
I know. I'm not there. I'm not done. So that's the first part. If you look at the second sentence, we do have some restrictions. We need to make sure that the diameter is equal to the height. And I want the height to be a whole number, so no fractions, no decimals. Okay? I want you to tell me how tall the tank is going to be. Okay? So if the diameter of the tank is the same as the height of the tank, how can I figure out how tall the tank is? How tall is the tank? So we're looking for this number here, the height. The height's a whole number. That doesn't make any sense. The height is how tall the tank is. Well, we'll try it. Let me show you. What's the volume? What's the volume of a tank, of a cylinder? Let's try it. Give me the formula. No. Pi r squared h. Okay. If the diameter is equal to the height, isn't that 2r? Okay.
My problem is that it says foot, right? So it'd be foot square, and then how much is the atom in foot cube?
He's talking about the units, and he's right. Okay. We need to be thinking of this in terms of cubic feet. Would you agree? Because that would make it a little bit better. So let's change that. Thank you, Marvin, for pointing that out. But that really does need to be cubic feet, not gallons. We could make the conversion. I could look up how many cubic feet were in a gallon, and we could do that. But for the ease of the problem, I agree. Let's just make the units the same. Okay? Someone on Smart, it's called the Smart Exchange. All right, so Smart Notebook, it's Smart Board. It's not because they're smart. Not saying they're not. They very well could have been. So this is the formula I want to use. Tell me what information I currently know that I could put in the formula to try to solve for what I'm looking for. I know the volume. So I'm going to replace the V with 5,875. I know what pi is. Would you agree? Okay. So here's the issue. I have an R and I have an H. And they're not exactly the same, but there is a relationship between them. The idea is to get one variable here. Okay? So hang on. Let's everyone think about it for just a second. We want it to be all in terms of the height or all in terms of the radius. Well, since we're looking for how tall it is, why don't we write everything in terms of the height? Is that okay? So I need to figure out how I can replace this and write it in terms of h. Okay? This is going to help us do that. All right? So we know that the diameter, I'm going to write it down here now, the diameter is equal to the height. Well, what's the diameter? 2 times the radius. So 2 times the radius is equal to the height. So if I wanted to, could I go ahead and plug in 2r for the radius if I wanted to? I'm sorry, 2r for this number. I could replace this with a 2r. Would that be okay? Would that maybe be the best thing to do here? All right, let's do that. So let's go ahead and plug that in. So I'm going to have r squared. And then instead of h, we're going to write 2r. Okay? All right. So let's keep going. I'm going to solve this for r. We have to have some skills to do that. If I have r squared and I'm timesing it by r, what is that? Do you guys remember that from Algebra 1? R squared times r is r cubed. So I'm going to say r cubed, and then I have 2 pi, and it's equal to 5,875. Well, I'm trying to solve for r. 2 pi. We good so far? So what is 5,875 divided by 2 pi? Again, I'm going to use that numerator-denominator thing. 5,875 divided by 2 pi, just so I don't have to worry about the order of operations thing on my calculator. And I got 935 approximately is equal to r cubed. Cube root. Very good. In order to solve this for r, I want to raise each side to the 3rd power. Cube root it. So where is that feature on the calculator? Math button. If you go to the math key, you will see the cube root. I could do the same. That is correct. I'm going to just, rather than round, watch what I'm doing for a second, please. I put the cube root, and it's telling me what do I want to take the cube root of. If I just arrow up and hit enter, it'll put it in without rounding. Just food for thought if you're interested in doing that, okay? And press enter. I get about 9.78 is the radius. Well, that's great and all, but that's not what the question asked. What did the question ask? We want the height. But guess what? If I know the radius, can I figure out the height? What is it? Just that number times 2. Yeah. So multiply by 2. And I get about 19.56. That's how tall this is going to be. You probably can't see that. The diameter had to be a whole number. That's a good question. How about we didn't do that, did we? I like ours better because ours is exact. Because nothing is ever whole numbers, right? What are the units, though? Feet. What I do after the radius for what, dear? Because 2r is equal to the height.
Wait, if you want the radius to be in higher whole number, why don't you use on it?
What?
So if you want the radius and the height to be a whole number.
I don't. I crossed it out.
No, but then
If you wanted to, you could.
round.
Right. I could round. But in real life, that doesn't ever happen. Okay? So let's be real life about it. Okay? In real life, things don't always work out as, 20, 19.56 is realistic. Okay? I thought that was a pretty tough problem. Okay? Being able to decide what the volume is, what is the relationship between the radius and the height, being able to look at the diameter as given into the problem. We got a lot of stuff going on in this question. Okay? If you would, go ahead then and look at this problem. It is also located in your packet. You just have to turn back a page. It's written at the bottom here. You'll see it kind of dark on your paper. If you'll flip back to it, that would be awesome. It's about the silo. Okay, do you see it on yours at the bottom there? Okay. So I'm going to pause the recording because this problem is very, very similar to number 6 on the homework. Okay? So I want you to think about this problem and how, and we're going to look at the surface area and the volume. And maybe I'll give the table that can come up with the correct answer first. I'll give you guys some dum-dums. I think I have some still. I think I just filled it up. Some candy. Okay? So work together. I want both the surface area, because it's asking for the total surface area of the silo. Let's say, what if we had to paint it and we needed to know what the surface is that we needed to cover? And then if you notice, the other key word is how much will it hold, which was a signal that means volume, right? So we're looking for surface area and volume. So go ahead and work together, come up with an answer to these, and then we will go forward from there. So I'm going to ask you this question. If we're worried about painting the silo, let's pretend that's the issue. Do you paint the bottom? So think about that when I'm asking you for the total area. Okay? So think about that. So we're not going to paint the bottom because it's on the ground. So we're really looking for something else. So because we decided that we're going to be painting the silo, that means we're really looking for the lateral area of the cylinder, only the distance around. I'm not worried about the top or the bottom of the cylinder. So we're going to do the lateral area of the cylinder plus half of the surface area of the sphere. Does that make sense? Okay? So that's what we're really looking for here, and that's going to be the total surface area. And when I did that, I ended up getting 170 pi, which is the exact answer, or 534 feet squared. Uh-huh. Okay. The volume, I thought was a little easier, but that was just me. For the volume here, you really want the volume of the entire cylinder plus half of the volume of the sphere, because it's a hemisphere. So we had to be careful as we put things into our calculator, because spheres tend to have fractions of 4/3 in there, right? So the volume of this I got to be 1,204.3 cubic feet. Okay? So that was a difficult problem. It's a matter of really thinking about what the question's asking and what information we needed to put in there. Okay? All right, so I'd like us to go ahead and turn. We have a few more minutes that I'd like to work on together. I have 3 questions I want you to do. I want you to look at it looks like this square piece of paper, like this. It's almost at the end. Well, not really. It's like in the middle. I don't know. Whatever. It's this one. Okay? Where you have 2 similar cylinders. You have a bale of hay. You see what I'm talking about? I want you to work on problems 1, 2, and 4. You can skip 3 for now. Ooh, that's a good question too. We need no. This is on an SOL from a released one. So we'll come back to that one now. Okay. So we'll treat this as our question. Is it 3 that we have to skip? We'll treat this as our question 3. Okay. But I want you to do problems 1, 2, and 4 on your worksheet that's in your packet on the word problems, and then we'll come back to question 3. Can everyone look at question 1 because there's a key word there? Similar. We did similar stuff several units ago, several months ago. And there is a relationship between, if it says the word similar, they are similar solids. Remember that for number 1, we can have the sides, we can have the surface area, and we can have the volume. Do you remember that? And if I have, this is squared, this is cubed. Do you guys remember that too? And we can go backwards and forwards, and we can write the ratios. That's what you're going to do in number 1. Maybe I was making it harder than it needed to be. What if I didn't give you the 8 at all? Could you do it with, you could do it without the 8. Did you know that? Well, I'm going to show you how. Can you please cross off 8 for me? Cross it out. Well, not really, but I'm going to make it a little harder because you can do it without that number. You don't need that number. Okay? The way you guys were doing it is fine because you were looking between 2 and 8 is a ratio of 4, a scale factor of 4, so the height has to be 4 times as big also. Perfectly fine. But without the 8, how would you do it? So let's look at that problem for a minute. Okay? I have a small cylinder and I have a taller or a larger cylinder, and they are similar cylinders. It says they're similar. I have 14 and 2, and I have 8. I don't have 8. I don't know what that is. And I just have two similar. They're just similar. No, you don't. If I know, maybe you do need the 8. I'm thinking. Can I show you what I was going to do? Let me just finish. Okay. So the volume of a cylinder is what? Thank you. Pi r squared h. Okay. So I happen to know that the radius here is 2, and the h, the height was 14, right? So what's its volume? What's the volume of the smaller cylinder? 56 pi, or we'll just say 56 pi. That's fine. Okay? Which is also whatever you said. Good. So if I have the 8, let's say I do, okay? That's fine. The ratio of the volumes has a different ratio than the ratio of the radii, right? So in other words, 2 is to 8 is not equal to 56 pi over the volume I'm looking for. They're not the same. Because the ratio of the sides has a ratio, and the volumes is the sides cubed. Do you remember that? So in order to answer this, if I wanted to solve for the volume, I could just do cubed cubed. You see what I'm saying? So let's try to solve it this way and see if you get the same answer the way you were trying to do it, okay? I don't know if you will or not. Let's just check it out. So if I do 2 cubed, what's 2 cubed? 8. What's 8 cubed? I don't know that one. Someone tell me what 8 cubed is, please.
512.
Thank you. 512. I should know that. And so I want to solve for the volume of the bigger cylinder, right? So I'm going to cross multiply. So 56 pi times 512. So big, isn't it? Okay. And then I'm going to divide it by 8. So I get about that number. Okay. 11,259. That's the volume I'm looking for. So that answer, it's not in terms of pi though. So how would I get it in terms of pi? Divide by pi? You did. So 3,584 pi. The answer is D. Okay. I just want to remind us about this because you can't always do it that way. There are some problems previous to this. If you turn back in this packet and look at 27, 28, 29, and 30, do you see those problems? 27, 28, 29, and 30? That's going to be part of your graded assignment. 27, just turn it back to the previous page. 27, 28, 29, and 30. Please circle those problems. You're going to be turning those in. No, you'll be due next class. But those 4 problems are part of your homework. or part of the graded assignment on 3D figures. You're going to end up turning this whole packet into me, and I'm going to be grading certain problems in it, okay? So and this problem here is to kind of remind you how to relate the similar figures. Remember, this was the part of the test when we did similar figures we didn't do so hot on, if you remember. Would you like me to do one of those problems with you so you feel comfortable turning it in for a grade? Okay, so why don't I pick 27? So I'll only grade 28, 29, and 30, okay? So we'll do question 28 together. So if you look at that one, just turn the page back and we'll try this one. That's the one I wanted to do. We're going to do 27. Yeah, I really need it to be the weekend right now, apparently. Yeah, after the SOL, sure. If you all pass. Yes. Never stop, Maddie. Never stop. Come on. I'm not going to quit. I'm not going to give up on you in your education.
Isn't this your last week teaching?
What are you trying to get rid of me?
What if, why?
I'm teaching AP Stats next year. Only. I'm not teaching, I'm the MYP coordinator. I still have to teach 2 classes. I'm not teaching geometry anymore. Or algebra 2. Not next year. I don't know what I'm teaching in the future. I might leave. I might die tomorrow in a car accident. I don't know. I mean, I hope not, right? But I mean, it could happen. Escalate. Let's not go there, right? All right, 27. So it says that the figures are similar. That's really important. If you see something like this on an SOL, it will say the word similar solid, okay? Similar is the key word. If they are similar, I want you to be thinking about the relationship between the sides, the surface area, and the volume, okay? So I have the 2 volumes. It's asking me to find the scale factor. Okay, so if you remember, we had the scale factor, the surface area, and the volumes. And it kind of goes this way. Do you remember? Okay, so the ratio of the volumes, what do I have to do to find the scale factor? I have to go backwards. So what am I going to do? Cube root. Okay, so I'm going to cube root the scale factor. So I'm going to cube root this, and I'm going to cube root this. And let's find the scale factor. I'm going to write it all over each other if that's okay. I'm going to use the fraction bar on my calculator. So if I plug it into my calculator here, I'm going to go to alpha y equals to get that fraction. And we're going to do math cube root 19 pi. And then come down to bottom, math cube root 152 pi. What's the scale factor? A half. Okay? But that alpha y equals will help here in that fraction stuff. So again, I'm going to officially assign questions 28, 29, and 30. Okay? So those are going to be part of the graded assignment that you're going to do and turn in for a grade for this 3D unit. That's what it asked for. Yeah. You'd find this, if it asked you for the surface areas, the ratio of the surface areas, you would go here and then you would square it. So the ratio of the surface areas would be 1/4 because it's 1/2 squared. Okay? You always go back to the surface areas and then do whatever you have to do. Okay? No? Yes? Sort of? Maybe? Okay, can we go back to the, don't keep working on these. You divide the one on the right divided by the one on the left. I don't care about being small or big. I'm going from left to right. So backwards would be from right to left. Or, yeah. If I needed to multiply this, the bigger one, by a half, I'd get the smaller one. Right?
So the bigger one is half.
It's right. So you can't say bigger, you can't say left, you have to go left to right, or right to left. Can't be always bigger, always smaller.
So that means the relationship of the left one to the
Right one
always.
is 2 to 1. Yeah. Okay. I'd like to end with this problem today. Okay, I know that we had the Hale Bay problem, and maybe I'll add that as part of our official assignment as well. I'm going to I'll tell you what they are before you leave today. Okay, but this is not in your packet, so maybe you draw it on the back. Okay, in your notes if you want, that's fine, or on a separate sheet of paper, that's fine too. But somewhere we need to have this problem. Okay, this was on a problem that was released by the state of Virginia, or a similar one anyway, many years ago. And it's a pretty good problem. Always causes kids to think. So we have a rectangular fish tank that's 2/3 full of water. I realize I drew the whole thing blue. Sorry. But I tried to draw a little line in there to show you 2/3 full. Okay? I've got the dimensions of the tank there. I put a rock in the bottom of the tank, because you know fish like rocks. It's a perfect sphere, because you know my life has to be just so zen. Can't be free form or anything. Perfect sphere rock. And the water level rose 1 inch. I want you to find the volume of the rock. Nope, don't need that. I don't care about that.
Like a problem of chemistry sometimes. I give you something like that and you find it.
I'm not worried about the mass. I don't care how much it weighs. I just want to figure out what the volume is. So give me a general idea what we would do here. Like give me what do I need to find? What's my plan? That's what I'm looking for. I can't find that yet. I got to do some things to find the volume of the sphere. The total volume of what? The tank? Okay, so I want to find the volume of the water before I put the tank in. Before I put the rock in. And then could I find the new volume after I put the rock in? So maybe find the volume of the tank before the rock, the volume of the tank after the rock, and then to subtract them. Would that work? Is that a plan of action that we could try to use? So that's what we really want to do. We want to find the volume before the rock, and we're going to subtract, or actually the other way around, isn't it? Because after will be bigger, won't it? So we need to find the volume after the rock, and we're going to subtract the volume before the rock. And that will help me figure out the volume of the rock. Okay? So maybe before the rock, if I multiplied 26, the volume before the rock, if I multiply 26 times 5 times 12, is that the volume of the water? Why not? Because that's the entire tank. How full is the tank? So I got to multiply this by 2/3. Tell me what that is. What is the volume of the water in the tank before the rock? $1,040. Okay? And that's feet or inches cubed. That's fine. How do I find the volume after the rock? Well, I need to figure out how high it is first. It's not 12 inches high. No?
26 times 5 times 8 equals 1,040.
Yes. My point is that I want to know how high the current water is. Maybe, okay? It's 2/3 of that volume, or the volume, it's 2/3 of this volume. Let's see if it is. I don't know, okay? But I do know if we found the current height, don't I know that 26 times 5 times x is that? So let's take 10,000 or 1,040 and divide it by 26 and divide it by 5. 8. Is 8 2/3 of 12? So Jonathan was right. Okay, so we're okay to do that. So this is going to be 8 inches tall beforehand. 2/3 of 12. This is before. I haven't done anything after yet. It's 8 inches tall before. The entire tank is 12 inches. It's not all the way full. It's 2/3 full. So the water level before I put the rock in the tank is 8 inches high. Is that better? Okay. It now tells me that after I put the rock in, it's raised 1 inch. So now how high is it? Now it's 9 inches high. Are we okay now? Okay. So now we're going to find the volume after the rock, and that's going to be, well, 9 inches times 5 inches times 26 inches. So 9 times 5 times 26. So 1,170 cubic inches. So what do I need to find the volume of the rock? Subtract them. Very good. So the volume of the rock is simply 1,170 minus 1,040. How'd you get? 130 cubic inches. That would be the difference in the volumes. Okay? I thought that showed up on an SOL years ago, and they've since released that question, so it's not a secret anymore. But I always like to do it anyway because it makes you think. And a lot of these SOL questions are word problems like this, so we got to kind of think about how we're going to do that. Okay. Yeah, there's always going to be some questions in there that don't count. We never know what they are. They're called field test questions, and I don't think you know what they are. I don't sure as heck don't know what they are. I don't think anybody really does except for the actual test people. Okay, so I won't know which ones count. You won't know. You just have to do your best on all of them. Okay. All right, so let me go ahead and officially assign your 3D graded assignment. Rather than have a test that I'm going to give you, it's kind of like a take-home assignment. So in your packet, so we're going to call it the take-home 3D assignment. And it's going to be kind of scattered throughout, so for that I apologize. But if you look where it says 3D Figures Practice Test, and Reese, I think I'm going to change what I initially told you, so I apologize, okay? I don't think I want you to do all problems on it, because I think that's just too many, okay? But what I would like for us to do is problems 1 through... Actually, let's just do the evens. Let's do 2 through 30 even. And so that way you don't have to do all the similar ones, but we'll just do 2 through 30 even. That will give us a combination of the similar solid stuff, volume, lateral area, and surface area. Okay, so it's going to be kind of a combination. Make sure you're following the directions at the top, okay? So just 2 through 30 even. And then I am going to have you, oh, that's good enough. That'll be good. All right, so we'll just do those. So 2 through 8, those will be graded for accuracy. I will tell you to make sure that you include your units. Okay? And that will be graded. You can start it now if you would like, but it will be due next class. Yes, sir. Absolutely. If you would like your formula sheet to take home with you again, so you have that with you, that's perfectly okay with me. I think that's a good idea, actually. But leave your binders here. Would you like to take them home to study with? I don't know if you would over the weekend, but I'm not going to grade them over the weekend. So if you would like to take it home, that's fine. Just bring it back with you. Do you have a question? No? Okay.